Well, it is here. This is the beginning of the video blog portion of the Microsoft Robotics at Home competition. I am one of the finalists, and I've been working on the code for about a week and a half, but tonight the robot arrived, and so we're kind of bringing things up a notch. It was a typical rainy day, but UPS called and they said I could come pick up the package, and so here it is. So we're going to do kind of a CNET, kind of a out of the box, you know, what's in the box as I open it up, and this will just be the beginning of hopefully a long series of these as I go through this project. Now, I'm not going to bore you with trying to put the thing together. Jessica does a great job showing you how to put it together. If I find issues that she hasn't mentioned, I'll go ahead and talk about those. Otherwise, I'll do more of the developmental side. So anyway, I hope you enjoy this, and here we go. Okay, so in the box here, they were nice enough to include a wireless Xbox controller. This will be nice because the size or the mass of this robot is bigger than anything I've ever worked with, and so having something that I can kill before it runs into the wall or the dog will be a good thing. I'll give you an idea here. This is the size of robot I'm used to working with here. So things are ramping up a notch. So anyway, put that back. We have the front and rear caster wheels. We have the part that makes this really interesting, the Microsoft Kinect. That will give it the three-dimensional vision using their structured light, their infrared depth camera, as well as the skeleton monitoring. So that is really, this is the MARC platform, and the K stands for Kinect, and so that's an important part of this. We have a power controller. We have the Parallax propeller board. Parallax, this is it's a processor with 8 cores that they call cogs, and it acts as the interpreter between the software that's running on the laptop, which is the Robotics Development Studio, and the actual sensors and motors of the robot. So it's kind of like the old hardware abstraction layer, HAL. This is sort of the robot abstraction layer. So anyway, there's that. Give you an idea, 2 gel cell lead acid batteries, so which constitutes a fair amount of the weight. What else here? These are the sensors. It's got 3 infrared and 2 sonar sensors. Here's the power control that switches the 12 volts to the motors and to the board. The motor kit, which is another important part. These are 12-volt motors, and they also got pneumatic tires on them. The motors also have wheel encoders, Microsoft Robotics Studio. The commands that you give it, you tell it number of degrees to turn, distance to drive, and so the encoders translate those commands into the hardware actions. The hardware to separate this has got 2 pedestals. It's got a lower pedestal that holds the motors and the control board and the motor and the batteries, and the upper pedestal actually holds a laptop, because this does need a laptop to run. That's a misconception that a lot of people have. They think that Microsoft Robotics Studio actually builds a program that you download into the robot, and it doesn't. It builds a program that runs on Windows 7 and communicates with the robot. And so here's the lower base of the robot and the other platform. So these are all the pieces coming out of the box, and now I have about 6 hours of assembly in front of me. I've finished assembling. The first thing you do is assemble the ping and infrared sensors. So I've assembled that's an infrared sensor mounted on its bracket, and there's a ping ultrasonic sensor. So put the cables on those, and then the next thing to do is to mount the battery tray on the bottom of the base. So anyway, 1 step down and about a bazillion to go. And then I'm about 30 or 40 minutes into it at this point. Okay, so when you hook the cable onto the infrared sensor, here's the infrared sensor, the cable has got a little keyway on it, so it can only go one way. But when you hook the ping sensor on, it says to make sure that it's polarized, to make sure you get the right polarization. But the labeling is actually on the side closest to the plastic mount, and so it's hard to see. Luckily, I had an extra ping sensor, and so I looked at it. So when you're assembling it, look from the back, the ground is on the right, and the signal, which is the white wire, goes on the left. So I discovered as I'm building the wheel caster assembly. This is what one of the completed ones looks like. This is a very precisely machined pieces of aluminum here, and so the tolerances are really tight. I mean, this is just, it's amazing. So you put actually bearings in this block of aluminum, and I mean they are tight to the point where you really, I don't know if you can see that, I rocked it in on that side, and then I give it a little push and I rock it in on that side, and I rock it in on that side, and I just kind of work it in there until it I don't want to make marks on the aluminum, but it's a side-by-side thing, and to get it to press in, because it just to get it absolutely perfectly lined up so that it just drops in would be really hard. So anyway, you do that on both sides. So there's just a tiny bit of flash from the machining, so take a jeweler's file and kind of clean that off there. Probably would not make any difference at all, but as long as this is going together, I really want it to be good. So okay, so that's good. So the collar goes between them, and then this plate goes in. And the first one that I did, this hex screw was turned in just a touch, and this the shaft went through the collar, but then I couldn't get it through the bottom bearing, and I mean these things line up so perfectly that it was offsetting the shaft a tiny bit, so I had to back that screw out. So if you're having a problem getting it in, just take that screw out a tiny bit. Also, it says that there should be about a 2.5 millimeter gap between the top of this assembly and the plate, and you use a 3/32 hex to tighten the collar, which also happens to be about 2.5 millimeters. So makes kind of an easy depth gauge there. Whoops. And then just tighten it down. So I'm assembling the caster wheels, and these parallax parts are pretty precisely machined. I mean, like, everything is an absolute perfect fit. So you got to be kind of careful when you're putting these bearings in, that if they are just a tiny bit off, they will not go in. So you kind of got to rock a little bit and get them just exactly lined up with the hole for them to fit. So you don't want to force them for sure. Okay, well, in Jessica and Tim's video, the motor wheel, or the wheel assemblies, became pre-assembled. In mine, they were a kit, which is actually kind of fun to put together. One thing that I might mention, most of the instructions are pretty straightforward. A little later on in the instructions, it says make sure a jumper is set. Well, once you on the motor control board. So anyway, so let me show you. This is the completed motor assembly right here. And the motor control board sets right there. But they work on a serial communication thing, so you daisy chain the controllers together, so they have an identifier on them. And the identifier is a jumper that is right there.
Once this thing is on the assembly, it's really hard to get to that jumper, and they have to be set differently. So they come with A and B both installed. Both those jumpers are installed. Okay, so the instructions say that for the right motor controller, which can be identified by, let's see if you can see it there, the RH right there, that you leave jumper A in position, but you remove jumper B. And so I'm going to remove jumper B there. Okay, so now we've uniquely identified this motor controller as belonging to the right assembly. One other thing, in the machining, once again, the machining on these things is pretty precise, as is the tapping. And so several times in the assembly of this, actually on motor controllers and on the screws on the wheels, for some reason, I guess it's sort of like, you know, if you drop bread with peanut butter on it, it always lands the wrong side down. The threads can be, let me see if I can actually make it work now. So you begin to turn it in, and you can feel a little bit of resistance, and you will feel no resistance if the screw is in right. This stuff is really accurate. So if you just back up the screw until you feel that click, and then spin, and then it spins very easily in. So so I guess once again, this stuff is just precisely made. Nothing takes force unless it says it needs to have force, like for example, whoops. Okay, picked up my screwdriver. Nothing takes force unless it says it absolutely needs it, and so you just back it up and make sure that it's threaded in correctly, and it'll go in very easily. I said about the only thing that takes any hammering really was there's a pin right here that will engage with the slot in the wheel, and you have to drift that in by tapping it with a really small hammer. And when I did that, I set this side of it against a wooden block, and then tap the pin in from this side. And you tap it in about halfway. So anyway, those are the only things that I saw on the assembly of the wheels. Okay, so one other thing about the wheels, there is a small inner tube inside of the wheels. They were kind enough to send some extras, and I have a feeling I know why. That's what the inner tube looks like. It's very small, and you fill it to 36 pounds of pressure. Now I have a 50-gallon air compressor, and I kind of had a feeling that if I used that I was going to blow the inner tube up. So I actually went out and ran to the big box store at about 1:30 in the morning and got a small bicycle air pump. It's got a little hose on it here, and you just screw it on there and pump the tire up. And it took like I don't know, 12 or 15 pumps was all to bring it up to pressure. This is really tight against the machine hub, and so I think I'm going to run and get some of those short valve stem extenders so that it's a little more comfortable if I've got to re-air the tires. I don't really know if I have to or not, but I'm just going to go ahead and do that. Okay, I'm installing the batteries now. Once you have the wires installed, you are supposed to turn the batteries around and snug them in between the two motor mounts, but obviously that's not gonna happen right there. So I'm gonna have to do just a little bit of re-engineering. There's a cable tie right down here, and I'm just gonna get it out of the way. I got plenty of cable ties, so I'll just go ahead and get these in position and then work on rerouting the cables, making them look nice and tying them down later. Yeah, that works much better. Okay, when they said when you install the batteries to place them in between the two motor mounts, and it would be a snug fit, and for me, I just couldn't even get them in. And so what I had to do was go around to the opposite side and loosen up the two button head screws that were holding the motor mounts to the base, so that I had a little bit of play in there. And then I got the batteries. Then I was able to put them in, and it was a snug fit. Got my wires routed around. So I'm going to go ahead and get the Delron battery tray mounted over here, and then I'm going to go around back to the other side and tighten up the button head screws. But that was the only way I could get these batteries to fit.
All right, well, after somewhere between 5 and 6 hours of assembly, I was also taking time to video this and take some pictures also. So, but anyway, it took about 5 or 6 hours to get Eddie fully assembled. Here you can see him. I got the Kinect sensor on the top, the laptop on the top disc, and on the bottom disc you can see here the motor drive. It's a differential drive. I have the casters on the front and the back of the robot. Have sensors around the bottom here, 2 ping sensors and 3 infrared sensors. These infrareds, you can adjust the angle. It can be looking either out at this angle, straight ahead. I have them at a 10-degree angle, which is the recommended angle to start with. So the control board is down below here, which is the parallel 8 processor control board. It's hard to see probably. Right back in here though is the wireless receiver for the wireless Xbox 360 controller. And this thing is heavy on the bottom over the 2 12-volt gel cells that power it. So anyway, we're going to show you how to fire it up and then take it for a little stroll around the basement.